In the previous video, we had learned about the electronic configuration of elements and types of elements of s and p orbital, p blocks. In this video, we will be talking about the d and the f blocks. So the d block is present in between s and p block, and f block is technically supposed to be placed in between, but it's placed down to avoid confusion. And let's get started. So first of all, the D block elements. So the D block elements are present over here. This entire chunk of the periodic table consists of the D block elements. So the first transition series, so first of all, the general electronic configuration is n-1d, 1 to 10, ns, 0 to 2. Now the reason we say this is because when after the 3p orbital gets filled, it is not the 3d orbital that gets filled, but it's the 4s orbital. If you do not understand the basis of this, you should probably go check out the energies and the electronic configuration of various elements that will help you understand, and the energy of various orbitals. Now, when 4s, after the 4s orbital gets filled, that's why you have two elements over here, it's the 3d orbital that gets filled. And that's why we have n-1d. So, which means in our fourth period, the third shell's d orbital is going to get filled. So n-1, d 1 to 10. So as we go from left to right, it goes from d equals to, n-1. So 3d1, 3d2, 3d3 to 3d10 for zinc in case of the first transition series. Now they are also called as transition elements because they are in between the S and the P block. Essentially, they form a transition between the metallic character to the non-metallic character. And so they are, since they're present in between these two blocks, they're called as the transition elements. And the penultimate orbital, d orbital, is getting filled. That's why you write n-1 d. Now the first transition series is present in the fourth period, and it goes from scandium to zinc. And here you have the 3d orbital filled up. Whereas the fifth, that is the second transition series, is present in the fifth period. It goes from yttrium to cadmium, and here you have the 4d orbital getting filled up. The next one is little unique. So sixth and the seventh period, you have the lanthanoids and the actinoids. So here you have lanthanum and hafnium to mercury, as well as so here you have the orbital. The d orbital is going to be 5d orbital, which is getting filled. And in case of the period 7, the 6d orbital is going to get filled, and it includes actinium, rutherfordium to copernicium. Now the properties. First of all, they're all metals and they are colored compounds. In fact, you have a separate topic called as complex formation, or I think it's coordinate chemistry, which deals with such compounds. So the colors of the elements that the colors of the compounds they form is quite beautiful. You have beautiful red color to a pale lavender color. So it's really interesting to look at them. And they form metallic complexes, as I told you. They show several oxidation states. So if you take iron, for example, it can lose either 2 electrons, so it'll form Fe2 plus, or it can be Fe3 plus. So they have a variable, that's just an example, but there are various elements which show a variety of oxidation states. Now, many of the D block elements act as catalysts. So catalysts are basically substances which speed up the rate of a chemical reaction. So one of the most commonly used catalysts is probably platinum. So they basically, these catalysts do not themselves undergo a chemical reaction, but they will just facilitate the speeding up of a chemical reaction. So the next is they show paramagnetism. So the paramagnetic electron is basically an unpaired electron. So some of these elements will show paramagnetism because they have unpaired electrons. Next, F block elements. Now, F block, as I told you, basically consists of our lanthanoids and actinoids. So the general electronic configuration for the outermost shell is N-2, F1 to 14, N-1, D0 to 2, and NS2. So N-1D is basically going to be, right. So it's 6 minus 1, that is 5D, and 6 minus 2, that is 4F. So you have 4F and 5D shells getting filled up over here. So they are also called as inner transition elements. The reason they're called this is because they are present in between the transition elements. So they're called as inner transition elements. Now, the first series are called as lanthanoids or lanthanides, and they're also called as rarer elements, whereas the second series are called as actinoids, and most of them are radioactive. In fact, the elements after uranium are called as trans-uranium elements, and most of these elements, especially actinoids, majority of them are radioactive in nature. Now, properties of F block elements, they are heavy metals and they have a high melting and boiling point. They form colored ions and have variable oxidation states. They're radioactive in nature. Now, with this, we finish the characteristics of elements of D block, whose electronic configuration is N minus 1, D 1 to 10, and NS 0 to 2. 1 to 2, and they are colored complexes. They form colored compounds. They have variable oxidation states. They're called as transition elements because they're present in between the S and the P orbital. P block. Characteristics of elements of F block. The configuration is N minus 2 F 1 to 14, N minus 1 D 0 to 2, and NS. So these elements are they are called as basically lanthanoids and actinoids. You have two of them, two sets of F block elements. Basically, you have two series. That is, the first one is called as lanthanoids, the second is called the actinoids. The first series are rare earth elements, whereas the second one are most of them are radioactive in nature. They have high melting and boiling points, and they show variable oxidation states as well. With this, we finish the electronic configuration and the various blocks in the periodic table. In the next video, we will be learning about the various types of elements.